Julian,
Yeah,
how are you doing tonight?
good. How are you?
Good. So do you have your final tomorrow?
The second half of it, yeah.
Second half?
Yeah.
What material are we going to cover tonight?
We should just, like, go over that packet again, because, like, that's my final.
Yeah, I thought that's probably what we would do here.
Yeah.
Let's just kind of start on page 1. And certainly if you see any of these problems that you want to go over, say so. But
Okay.
otherwise, I'll just kind of look at them randomly and re-ask them.
Okay.
I guess we can do that. These kind of have the answers, the answers circled.
Yeah.
What's the value in number 3? Value of x plus y.
So, wouldn't it be 180?
No. Here, let me draw it so we can look at it a little bit better. Oops, shrunk the wrong thing. We have two parallel lines, and we have a transversal. Now, I'm going to draw a bunch of angles here.
Okay.
I'm not going to draw them, I'm going to label them. I want you to tell me what is true about angles 2 and 3.
They are, I forget the word.
Okay, the answer is going to be they are either supplementary or they are the same. That's the only two answers you can get.
They're the same.
Any of these questions. Okay, good. So 2 is the same as 3 because they're both obtuse.
Yeah.
In other words, every angle here from 1 to 8 is either acute and is the same as 1, or it's obtuse and the same as 2.
Okay.
So this problem says this angle right here is 131 degrees.
Yeah.
And they're saying, what is 4 plus 5?
So those are both acute.
Which means?
49.
So they're both the same?
Yeah.
Yes. If they're both acute, then they are the same. In other words, you cannot have two acute angles that are different in this picture. Nor can you have two obtuse angles that are different. All you have is acute angles or obtuse angles. The obtuse angles are equal to 131 and the acute angles are equal to 49. So 4 is the same as 5. Y is the same as x.
Okay.
And if x is 49, then y has to be 49. So their sum is 98.
Okay.
They are not supplementary, they are the same. But you have to, 5 is supplementary with 131. That's what makes it 49.
Okay.
remember this one being upside down. Is it possible we missed? No, I remember this problem.
Yeah, I don't know.
What is true? Which of those following statements is true?
Well, C.
Does a circle mean that's the answer? Or is that just what you answered when you went through it?
That's what I answered when I went through it.
Okay. One moment. I'm looking. So A cannot be right because they haven't labeled any angles here.
Yeah.
So we can't say any angle in that picture is anything. So neither A nor B can be right.
Okay.
D, E, and G, E, B are alternate interior angles. Are they not? Am I missing something? In other words, CBE is this angle right here. It's an acute angle.
Yeah.
It's an acute.
No, wait, yeah, they are alternate interior.
Yes, they are. So D is correct because they are alternate interior angles.
Okay.
EB. So this one and this one are not only equal, but they're alternate interior angles. Now, let's look at this one. DEB and CBE are not corresponding. They're actually different. Notice DEB is obtuse. CBE is acute. So those two angles are supplementary. They add to 180. We know that.
Okay.
And corresponding would be DEB and CBA.
Oh, okay.
And they would be equal. DEB is equal to CBA because they are corresponding. But C is not correct. Which of the statements is true?
Side angle side?
Very good. That side, that angle, that side.
Yeah.
What's the postulate on number 6?
Angle side angle?
So tell me what the angle and the side and the angle would be.
The right angle, the middle line, and then the angle A.
The middle line, they don't say that AB is equal to BC. We don't know that AB is equal to BC.
Okay.
We do know that angle C is equal to angle A.
Yeah.
And we know that this is a right angle, which means this is a right angle.
Yeah.
So you can draw a little right angle thing there. So we do have two angles that are equal.
Yeah.
What else do we have that is equal?
A side.
Okay. Where's that side located relative to those angles?
CD or AD.
No. BD is equal to itself.
Oh, BD.
BD
Okay.
is the side for this triangle and this triangle.
Yeah.
So we have angle, angle, side.
Okay.
Or looking at this triangle here, we have angle, angle, side. In other words, whatever postulate you come up with, you got to be able to find that. You got to be able to identify it in the order that it comes.
Yeah.
In other words, your first answer would actually have been correct, angle, side, angle, if they would have told us that AB is equal to BC, but they did not.
Okay.
You can't use that. Now, it turns out that AB is equal to BC only because we've proved those two triangles are congruent by angle, angle, side. And because they are congruent, AB is equal to BC. But
okay.
you got to work with just the stuff that they give you. In other words, you can't assume that AB is equal to BC.
Yeah.
And they also didn't tell us that AD was equal to CD, even though it is.
Yeah.
But they didn't tell us that, so we can't use that information.
Okay.
Well, my voice is about to give out. Just in time. I've got one more session tonight and a couple tomorrow, and then I'll have 3 weeks off. My voice can heal. So what's the values of X and Y?
So
hopefully you're not reading from notes here, right?
well, I have the paper in front of me, but like I'm just doing it again.
Okay, that's fine as long as you don't have the answers on there.
Yeah, no, I
I'd
don't.
rather you tackle these from scratch if we're trying to prepare you for this test.
Yeah.
Okay, good.
So you have to find 180, right? So is it 180 minus 96?
Well, what angle would that be equal to? Yeah. In other words, geometry is all about subtracting from 180, right?
Yeah.
And you have to do that over and over and over. So what's 180 minus 96?
84.
Good. So
okay.
that angle is supplementary with that angle, correct?
Yeah.
So this angle is 84.
Yeah.
What's Y?
Wouldn't it be 84 too?
Correct, because it's an isosceles triangle. Not only are the sides equal, but their opposite angles are equal. So Y is equal to that. So we got 84 there. We got 84 there. What's that leave for X?
Just 12.
Yeah, and you can kind of figure that out by looking at the answers. In other words, you don't really have to do the math there. There's only 2 answers that are anywhere in the ballpark. So 12 and 84. Let's go through each of these. Is A true?
A is congruent to 2. No.
Why not?
Because one's obtuse and the other one's acute.
They both look acute to me.
Oh. Yeah.
Okay. Don't be fooled by the perspective that they have thrown into this problem.
Okay.
The fact is that angle is not 90 degrees. If I wanted to make a 90-degree angle, I'd have to go perpendicular from that line.
Yeah.
So that thing's a lot less than 90 degrees.
Yeah.
The only thing that makes it difficult to see is the way they have drawn it. In other words, they kind of make it look like it's a 90-degree angle, right? Because of the perspective they've shown at it. In other words, if I draw it like that, that would be a 90-degree angle. Although they haven't quite drawn it like that. This thing is not really at a 90-degree angle. It is more like that.
Yeah.
So the one thing you absolutely have to be able to do in geometry is distinguish between an acute and an obtuse angle. And that skill merely requires you to be able to draw a perpendicular. If you can draw a perpendicular, then you can figure out whether an angle is obtuse or acute. Notice that in my drawing here, if I go from this point here and I draw a perpendicular, it's like that. Okay? That means this angle is 90 degrees, therefore the angle that's there right now is acute.
Okay.
And this one has to be obtuse because they are supplementary. They are always supplementary.
Okay.
So, let's look at B. Is 2 congruent with 6?
2. Yeah.
How about C? Is 5 congruent with 3?
No.
Which one is acute?
5.
Okay, again, if I go over here and I draw a perpendicular line, that is not acute, that is obtuse. Angle 5.
Okay. Okay.
So is 3.
Yeah.
In other words, if I go up here and I draw a perpendicular, it comes out right here.
Yeah.
So 3 has to be the same as 5 if they're both obtuse.
Yeah.
And finally, 7 must not be the same as 4 because 4 is acute.
Yeah.
7 is obtuse. Which theorem guarantees that L is parallel to M?
Alternate exterior.
Good. This is such a key skill that let's go over this one again. Number 10. Both 10 and 11. You don't want to miss these. These are algebra questions. And they're also geometry questions. What's the slope of this line?
-8.
What's the slope of the line that they want us to give them an equation of?
Isn't it -8?
Uh-huh. So the slope of our particular line, of the line that's parallel to this one, is -8, and it passes through this point. So how do I figure out what the equation of that line is?
You gotta plug it into whatever that equation's called. Y equals mx plus b.
Okay. Good.
So -2 equals 7 times -8.
Good.
Plus b.
Okay.
Is that -56?
Uh-huh.
Alright, so add 56 to both, to the...
Okay. Next line.
54 equals b.
Okay. What's the answer?
C.
Correct. What's the slope of a line that would be perpendicular to this
line? Positive 8x?
No, you got to do two things.
Oh yeah, the fraction.
First of all, the slope does not include x. The slope is a number.
Okay.
So it's not 8x for parallel or perpendicular. The parallel slope is minus 8.
Okay.
You have to do two things to get the perpendicular slope. What are they?
You gotta flip it and do the opposite.
Okay, so what do you get when you do that?
Positive 1 over 8?
Yes.
Okay.
So now let's do 11.
Okay.
So they give us this equation. This is a line. They don't want the equation of this line. They want an equation. They don't even want an equation. They just want to know what the slope is of a line perpendicular to this line.
Yeah. So just put it in the right order.
Okay.
So 9y equals minus 2x plus 8.
Come on, we can't move that minus 2x to the other side and have its sign stay the same.
Oh yeah, we gotta plus it.
Okay.
Alright, and then divide by 9.
Yeah. So now we get y equal 2x plus 8 over 9. That is the equation of this line.
Yeah.
So what is the slope of a line perpendicular to this?
Negative 9 over 2.
Good. In other words, the first thing you need to do is figure out what the slope of this line is. And
Yeah.
I tried to trick you intentionally here because you might end up writing it like this when you're solving it. It's important that you know you can separate this. In other words, as long as I have a single number in the denominator, I can write this like this. And now it's a little more easy to see that the slope is 2/9.
Yeah.
And that makes the perpendicular minus 9/2. So,
Yeah.
okay, good. I think you're getting this stuff. I
Yeah.
think you're learning it. I kind of actually like this. You're the second student that I've had this problem with where we ran out of problems and we went back and redid the ones we'd been working on for like 3 hours. And it was helpful going back through the same problems.
Yeah.
As long as you don't have the answer staring you in the face. I mean, you want to have to figure these out from scratch.
Yeah.
All right. How are we going to do this one?
Don't you just add those two together and minus it from 360?
Why 360?
I don't know, just because they go past 180.
Well, turns out you're right, I think.
Okay.
But that's 215, yeah. So that would give you 145. When I say I think that there's a theorem that says the sum of the 3 exterior angles of a triangle is equal to 360. But you know what? The problem I have with that is that how come that's not one of the exterior angles?
Yeah.
Or how come we're not talking this angle, this, this? In other words, I'm not comfortable relying on that.
Yeah.
Also, I don't think it's a theorem you've talked about before. I do think it's a theorem. I think that matter how many sides there are, you can sum the exterior angles of even a 20-sided figure, and it always adds to 360. But I think that depends on how you create those exterior angles. And it's not clear here how they're being created because each side is extended. Like I said, is this the exterior angle or is this? I'm not comfortable using that theorem. What's another way to do it? What's this angle right here equal to? In fact, let me draw this problem. First of all, before I answer it, I want to give you a little bit more time to look at it and think about it, because I feel like you should know how to do this. Oops, excuse me. I labeled it wrong. This is x.
Okay.
What's this? Let's not even worry about that for the moment. This is, x is not the place to start. The place to start is with information that they give us that allows us to figure out other stuff.
Yeah.
Well, they give us these two angles. What can we figure out from those two angles?
The interior angle?
Yeah. What's this angle here?
Is this an isosceles triangle?
No, you don't need to even, it wouldn't matter.
Okay.
These two angles are what? 88 and this one are what?
53?
No, they're supplementary.
Oh, supplementary.
Anytime you have a straight line and another line crosses it, angle A and angle B are supplementary, always.
Okay.
Okay, well, we have a straight line there. There's 88. That's got to be 92.
Okay.
So let's label it. What's this angle here?
53.
Now, we can figure out what this angle is. What is it?
Yeah. 35.
Huh? And now we can figure out what x is. What's x?
145.
Okay. Now, I know a good thing to do. Good practice for you. No calculator.
Okay.
I want you to subtract the following numbers from 180.
Okay. So that would be 80 or 76.
Okay. Now, notice how I know that is right.
Yeah.
So I add them back together again. It's real easy to add those up to 180, right?
Yeah.
So I want you to use that technique when you subtract them.
Okay.
When you subtract them, just kind of experimentally play with answers. We know this digit kind of has to be a 7, doesn't it? These two digits always need to add up to 7 because there's going to be a singles unit digit that's going to add up to 10. So unless this is a 0, in other words, if I say, well, that, then this has to add up to 8. But if this is any digit other than 0, then know that those two middle ones have to add to 7. Okay. So if I said subtract that from 180, what's this digit got to be? Has to add to 9 to end in 7.
Wait, it has to add to 9 to end in 7?
Yeah, in other words, it's got to be 8.
Okay.
Because that ends in 17.
Yeah, okay.
Okay, 7 is the magic number, not 8.
Okay.
7 is the magic number. We know that these two have to add to 7 as long as this is anything other than 0. And then, of course, this has to be what? Because now we know these two have to add to 10.
8?
Uh-huh.
Okay.
And this is a much easier way to do all these subtractions from 180.
Yeah.
I'm going to keep drilling you here.
Uh, 110?
Okay, that's easy.
Yeah. 117? Wait. No, 107?
Notice, must add to 7.
Yeah. Okay. $158?
What'd you say?
$148?
Okay, notice. Notice how fast you can do these when you know this little trick.
Yeah. 121.
Beautiful.
Um, 89.
Now, why is it so important that we always be able to subtract from 180? Because almost every geometry problem is something like this. What's the third angle? Well, what do these two add to? Add those two in your head quick.
50, 100, 118.
What's the third angle? What's this digit? What's this digit have to be?
6.
What's this digit?
And then 10, 62.
There you go.
Okay.
Okay. So every time we're dealing with triangles, we're subtracting from 180.
Yeah.
Every time we're dealing with supplementary angles, we're subtracting from 180.
Yeah.
In other words, if I give you this one as 75, this has to be 105. We got it by subtracting from 180. So subtracting from 180 is just something you do over and over and over again.
Yeah.
All right, let's go back to our problems. So you were right originally. That angle plus that angle plus that angle do total 360.
Okay.
However, before I confuse you, let me just review that theorem. If I take a four-sided figure,
Yeah.
and I make just one exterior angle,
Okay.
like that, where I'm talking this angle A, B, C, and D,
Okay.
those have to add to 360. And if I have a five-sided figure, and I make the exterior angles consistently, like this,
Okay.
A, B, C, D, and E add to 360.
Okay.
Okay, so there is that theorem. You haven't really had it yet, I don't think. So
No,
you couldn't really apply it to that problem, but notice why we would have a hard time applying it anyway, is that the picture they drew didn't draw it the same way I just did. When I drew it, I drew only one exterior angle in both cases. I didn't draw it by making these lines crisscross.
Yeah.
The way they drew their triangle, they have lines coming out of every vertex in both directions. So it wouldn't be real easy to figure out which of the angles add to 360.
Yeah.
That's why I wasn't comfortable saying that that had to be the answer. The more comfortable way is to figure out the inside angles and then figure out that angle and know that that angle is supplementary to x.
Yeah.
All right. Now, there is one problem that you have probably learned that's easy to forget, and that is this fact about a triangle. If you have a triangle with only one exterior angle, it's equal to the sum of the two angles that are not, in other words, the other two angles of the triangle that this one is not supplementary to. In other words, 3 is supplementary to 4.
Okay.
And that's why it's equal to 1 plus 2, because 1 plus 2 are also supplementary to 4.
Yeah.
So therefore, 3 is equal to 1 plus 2. And we had a problem earlier. Now, the reason not everybody remembers this theorem is because you really don't need to remember it. In other words, it's pretty easy to figure out everything here without knowing that theorem. Because I know this is 180 minus 3 automatically. And then I can figure out everything from there. So, but it does save a step or two if you're given a problem like that's 120 degrees. We got angle X, Y, and Z. What is X plus Y equal to? Well, 120. We can't tell. We can't tell what X or Y are equal to individually. In this picture here, I know Z is 60, but I don't know what X and Y are. They could be pretty much anything, depending on how I've drawn the picture. But what I do know is that they add to 120.
Yeah.
All right. Okay. Use that knowledge on this problem right here. What do I know about X plus 66?
That it equals, alright, wait, so I have to find...
Well, just tell me give me an equation that is true. The way to solve all problems, geometry or otherwise, is to get an equation.
Okay.
So 117 is equal to what?
63.
No. In terms of what I was just telling you about, an exterior angle is equal to the sum of the other two.
Wait, I'm confused.
Okay. This is an exterior angle.
Yeah.
It's equal to the sum of the other two angles in the triangle that it is not next to.
Okay.
So I can say 117 equals X plus 66.
Okay, yeah.
Now, this is a much easier way to do this problem, because now all I got to do is subtract 66 from the left side to get 51.
Yeah.
And there I'm done. If you do it the hard way, let's do it both ways, because this is for some reason, a difficult one to remember, and I believe it's that way because I don't need that theorem to solve this problem.
Yeah.
Notice how else I can solve this problem. I can figure out what this angle is.
Yeah, that's what I was trying to do.
63. I should have let you do it. In other words, the 1 and the 6 have to add to 7. So that's 63, and now figure out X.
So 63 plus 66, or...
Yep. Right, that's 129. Now what's x?
Okay.
What's x based on that?
51.
Right. So, but notice that that was one step, and then adding those is 2 steps, and then subtracting that from 180 is 3 steps.
Yeah.
As opposed to 1 step the first way. The first time I did it, I had one equation only that solved with 1 step. In other words, I said 117 equals x plus 66 and pretty much done.
Yeah.
How am I going to do 14? Set it up for me.
So 3x plus 2 plus 4x plus 2 plus x minus 1 equals 180.
Uh-huh. That's when I say set it up, that's what I mean. And then now it's just a question of solving a simple algebraic equation.
Yeah, so I gotta add all the like terms.
Yeah. Are there any questions about how to solve that?
No, I think I got it.
So what's the next line?
4, 5, 6, 7, 8x.
Okay.
Plus 3
Uh-huh.
equals 180.
Uh-huh.
And then minus 3.
So now you have 8x equals
177.
All right.
And then divide by 8.
Right. I keep saying right. Understand that I can't really see the signs on these things. I don't know if that's a +2 or if that's a +2.
Yeah, it is plus.
That's plus and that's plus and this is minus? Okay.
Yeah.
Then you're right so far. Okay.
Alright, and then...
Now how come you don't see that answer on anywhere there?
I remember us talking about this last time. It's because like I did something at the beginning that I
No, what do you get for x?
22.125.
How much?
22.125.
Okay. So what is this angle here? The bottom one.
21.125.
There you go.
Oh, okay.
What is this angle up here?
66, 68.4.
Okay. What's this angle here?
90.5.
Okay. You finally started looking down here.
Yeah.
Okay. Notice that as soon as we found this angle here was 21, we're done. There's only one answer that has a 21-degree angle.
Yeah. Yeah.
But the key here is you're not solving for x.
Yeah.
They want the measurement of each angle. So you have to do 2 steps. You have to solve for x, and then you have to substitute it in to calculate each of those angles.
Yeah.
It's the equation. What are these angles?
170.
Okay, let me give you another one.
Um, 140. 160. Wait, 80?
Uh-huh.
Okay.
So you took 180 minus 20. You got 160.
Yeah.
Right?
Then divided by 2,
You
yeah.
just have to take half of that. want to get good at taking half of numbers. There's no way taking half of a number should require pencil and paper or a calculator or anything. What's half of 100?
50.
Half of 150.
125. Wait, 75?
75. Half of 90.
45?
Huh? Notice that when you take half of numbers that begin with an odd number, the very first number is always the greatest integer of half that. In other words, half of 9 is 4.5. Just go with the big number. And then this is always a 5, so it's easy to take half of odd numbers and even numbers. Now, this might present a little bit of difficulties, but not really. If you know half of 3 is 1.5, so I know it's got to have a 1 there. I'm going to drop anything after the 1.
Okay.
Now it's got to be an 8, because twice 8 is 16.
Yeah.
But it's a little harder to take half of numbers that begin with an odd. And of course, taking half of this number becomes really tough because now you get a fraction. You get 17.5. Well, can't hardly do 16 again because I know you remember the answer.
Yeah.
Let's go to page 6. Set up the ratio on 18. Don't solve it, just set it up.
Okay, so should I do x over 14 or 14 over x?
You can do either way.
Alright, I'm going to do x over 14.
As long as you know how to solve what you get, it doesn't matter.
Okay. So x over 14 equals... Wait, so do I solve y now, or...?
No, I'm sorry, I should have said. Set up the ratio to solve for x, and then we'll attempt.
Oh, okay. So equals 5 over 8?
Okay. Now, notice why this is easier to solve than if you had x in the denominator. This is solvable by multiplying by 14. Done.
Yeah.
If we had this, if we had 14 over x equals 8 over 5, which you also could have done, we can't solve it in one step. There's no way to do one multiplication and solve this. You have to cross multiply.
Yeah.
To get 8x equals 70, and now you have to do another division to get x equals 70 over 8. So if you have a choice, always put your variable in the numerator and you'll save yourself one step.
Okay.
How do you set up to solve for y?
So y over 7 equals 5 over 8?
Don't switch.
Oh, wait.
Don't switch them. That's the only mistake you can make on these, is to switch the order. If you're going to go big over little, then stay big over little.
Yeah. So 8 over 5.
And notice that it's perfectly fine to do the first one, little over big, and do the second one, big over little. That's the most efficient way to do it because it keeps your numerator, your variable in the numerator in both cases. So there's no rule. There's no rule that says you have to go little to big or big to little. You just have to choose one and stay with it for that ratio. You don't even have to stay with it to do the different variables. But you have to stay with it to do that problem.
Okay, so now you multiply by 7? Okay.
Which gives you 56 over 5.
Yeah.
You can leave that as the final answer. 50. You can't leave the answer like this, but you can leave the answer like this because that cannot be reduced.
Yeah.
I can turn it into a mixed fraction, 11 1/5, but there's no rule that says that mixed fractions are superior to improper fractions. I prefer one term. I prefer 56/5 to 11 1/5.
Yeah.
I think it's a better answer myself.
Yeah.
Okay, 19. Set up the ratio to solve for x.
X over 15. Wait, no. X over 19 equals 97 over 15.
You got two choices. You could have taken 97 over 15 or what?
6. Wait, 39.
You could take 97.5 divided by 15, or you could take 39 divided by 6.
Yeah.
Which one's the easier ratio to deal with?
39 divided by 6.
That's the one you want to do then. I mean,
Okay.
just look at the difference in the math.
Yeah.
Would you rather do that problem, or would you rather do this problem?
The second
Yeah,
one.
it's a lot easier.
Yeah.
Okay. Now, you don't usually have that choice. There's not going to be that many problems where they're going to give you, and you're going to actually have two corresponding pairs of sides that you know. Usually one of these is not given, and you're forced to take whatever one you see.
Yeah.
So this time, set up the ratio. In other words, what they're asking about is this vertical distance right here.
Yeah.
So set up we'll call that x.
Okay.
I'm going to put a little x right there.
So wait, does it matter which order I put it in? Can I be like 60 over 24, or does 45 over x have to be first?
It's either one, because you have an equation that you... I personally think that you should always start with x as your first thing you write.
Okay.
Merely because that helps you... it forces the x to be in the numerator.
Yeah.
Okay? So what's the first part of the ratio? If you always start with x.
X over 45.
Okay. Now let's figure out two other corresponding sides. So x over 45 equals what?
24 over 60.
Yeah. And that's why I always start with x. Because for one thing, if you do the other number first, if you start with 60 over 24, say, now you don't know whether you're going to end up with x in the numerator or the denominator.
Yeah.
I would have ended up with it in the denominator. And you don't know that going in. So if you always begin with x, that forces your left term to have the x in it, and it forces the x in the numerator.
Okay.
So I would always begin that way, is the side they're asking about, start your ratio off with that.
Okay.
This angle right there.
Well, since they're both right angles, that makes it the same. So 51.
Yeah. What it does, the fact that that is a right angle and that is a right angle makes ED parallel to BA.
Okay.
That's what it means. And the fact that ED is parallel to AB means that angle is the same as that angle because of the parallel, and that's a traversal. CB is the traversal. You have two traversals. You have CA as a traversal and CB as a traversal. We use CA and the fact that these are 90 degrees to come to the conclusion that that's parallel. These are parallel. Once we know they're parallel, now we use that, comparing that traversal with the others. All right. Set up this ratio.
All right.
22. Just set it up. We'll call AQX because that's what they're asking about. So that's here. Let me put a little X there. I can't rotate it.
So would it be X over 18? Or?
Turns out that either of those ratios works. But that's not really the way you should look at it. What should X be compared to?
10.
Right. So it really should be X over 10 is equal to what?
18 over 12?
Yeah. Well, if you notice, that is the proper ratio, but it happens to be the same as the other ratio. In other words, if I say X over 10 equals 18 over 12, that's only true if 12x is equal to 180, right?
Yeah.
Well, if 12x is equal to 180, then I can divide this by, that also means that x is to 18 as 10 is to 12. In other words, with figures like this, you've got double ratios that work. In other words, I really can say x is to 18 as 10 is to 12. Notice that if I cross-multiply that, I get 12x equals 180. The same thing I got when I cross-multiplied this. If my cross-multiplication is the same, then this is a valid ratio also. But I hate to see you look at it like that. It can get confusing because if you start doing these problems thinking you can go any which way, then you might find a figure where you can't get away with doing that.
Yeah.
And so I would always say do the corresponding side, I guess. I don't know. I might be wrong there, actually. Might be just as acceptable to do x over 18. I know it's the same answer, but
yeah.
I don't know. I find it...
Well, 10's easier anyway. So.
Well, that's true. Multiplying by 10 is easier. I'm just thinking about it conceptually. I'm not I wouldn't be 100% sure that x is to 18 as 10 is to 12. I am 100% sure that x is to 10 as 18 is to 12.
Yeah.
So take it from there. But
okay.
I think you know this stuff pretty good, Julian. I think you think you did pretty good on your first half of your test today?
Yeah.
Good. Go to it. Do good tomorrow. I think you will.
All right.
Have a good holidays. I'll probably talk to you after the holidays next year.
Yeah, okay. Thank you.
All right, you're welcome. Bye-bye.